Hello and welcome to today's session. My name is Rajesh, and today we'll be looking at the introduction of ISO 8583. Typically, whenever we use credit card or a debit card or an ATM card, the data travels from one system to another. A card-based transaction typically needs to travel between number of systems. For example, a purchase made in a store may travel from the merchant terminal through another acquirer network or networks to the issuing bank where the cardholder's account is held. The transaction carries information about the type of transaction, the card used, the merchant information, the transaction amount, the security information, and so on. The response or authorizing or declining the transaction needs to be returned via the same route to the terminal. The data interchange that takes place between different systems needs to follow standard formats for integration, exchange, and interoperability. So there are many such standards existing. In financial world, there are standards or protocols like ISO 8583 or ISO 7816, etc. for various kinds of data interchange. ISO, or International Organization for Standardization, is a worldwide federation of national standard bodies. ISO 8593 is Financial Transaction Card Originated Interchange Message Specifications adopted by wide segment of payment industry, which includes acquirers and issuers. The ISO 8583 specifies message structure, format, and content, data elements, and values of data elements. Application specification may remain at private level or implementer, and the method or the message by which settlement takes place is not within the scope of ISO. Cardholder originated transactions include purchase, withdrawal, deposit, refund, reversal, balance inquiry, payments, and inter-account transfer. The ISO 8583 also defines system-to-system message for secure key exchange, reconciliation of totals, and other administrative purposes. So let's look at the message structure of ISO 8583. The basic structure of an ISO 8583 message is comprised of a series of data fields whose presence is controlled by one or more bit mask field. Each of these fields has a format definition that controls the serialization and indicates the type of information present, for example, a numeric or a text. So it is this schema that allows the raw data to be passed into corresponding structure and vice versa. So as the bit mask fields signify the presence of other fields, they themselves have little value to the end user and equally can be calculated when serializing rather than expecting users to perform the calculations. This means that the representation in, say for example, any integration testing tool has removed this sort of simplicity. So let's have some observations made on the message type indicator, or rather MTI. So MTI, or a message type indicator, is a 4-digit numeric field which classifies the high-level function of the message. A message type indicator includes the ISO 8583 version, the message, the class, the message subclass, and transaction originator. Different versions of ISO 8583 standards are indicated in the first position of the message type indicator. So by knowing the MTI value, we can identify the message type. For example, if MTI value is 1200, then from the table above, we can find other details. First position is for version number and value in MTI is 1. So message version is based on ISO 8583:1993. Similarly, second position is for the message class and value in MTI is 2. So message is a financial message. Third position is for subclass for a function and the value in MTI is 0. So the given message is the request message. Similarly, the fourth position for the transaction originator and the value in MTI is 0. So the message is coming from acquirer. When we consolidate all this, we do find that message with MTI value 1200 is an ISO 1993 financial request message sent by the acquirer. So what does the bitmap and the field formats look like and what do they indicate? So the bitmap is an indexing technique used in an ISO 8583 message to indicate which data elements are present. The presence of the data element in a specific message is indicated by 1 in the assigned position, 0 indicates the absence of the data element in the assigned position. So each application transaction includes one bitmap. A bitmap consists of 64 bits numbered from the starting left starting with bit 1. The first bit of the bitmap represents a secondary bitmap. If any ISO message does not support secondary bitmap processing, then the first bit of the bitmap is 0. So a message contains at least one bitmap called the primary bitmap, indicating the presence of the data elements 1 up to 64. A secondary bitmap may be located at data element 1 and hence the first in the primary bitmap tells us whether there is a secondary bitmap or not. The secondary bitmap indicates a presence of data element 65 up to 128. A message can obtain up to 3 bitmaps in the latest version of ISO 8583 standard. The bitmap may be transmitted as 8 bytes or a binary, or sometimes with 8 bytes unpacked into 16 or a hexadecimal character starting from 1 to 9 or character from A to F ASCII values. So within the schema definition, the definition for every field specifies the permitted content type and more importantly when it is fixed or variable length, with variable length being expressed as the number of digits that precede the data. So one of the complications of the specification is that the bit mask field and the numeric prefix of variable length fields can be serialized in vendor specific ways. For example, state binary or BCD, the raw hexadecimal form, or the ASCII representation of the value. So integration tools for Raster Integration Tester has support for several of these, including sample schemas for some of them. I hope this session was helpful. Thank you for watching this video.